Okay, I have a simple circuit set up here. Notice there's just a wire going from a power supply through a light bulb and a switch. And notice that when I flip the switch, and this is where you need to get a little bit closer here. When I flip the switch, watch what happens, how fast the light turns on. Okay, basically instantaneously. Okay, I can make it go on a little bit faster if I give it a little bit more voltage. There, notice that there's no delay. Okay, now this over here is a whole bunch of solenoids set up together. Solenoid is just a bunch of wire wound as tightly as it possibly can. And now I'm going to take this electricity, and instead of going straight through the light bulb, I'm going to go through the solenoid instead. The solenoid, let me just point out, the wires themselves have a little bit of resistance because, wires have some very basic resistance, but there are no resistors. This is still just wire. Let me turn up I'm going to have to turn this up a little bit just because, again, the resistance of the wire. But now notice what happens when I flip this switch. Okay? Ready? Notice there's a significant delay. I can reduce that delay a little bit, just to give you a little bit more idea. You'll notice inside these solenoids here are a whole bunch of rods. These rods are the ones that we use for ring stands and so forth, and the reason for using them, well, they're just made out of metal. They're made out of steel, and they're made out of steel, which has iron in them. Now watch what happens here, how the delay changes when I take the iron out. Get in? Okay. There's still a delay, it's just not as pronounced. Now why is that? These are what we call inductors. Let's wait till that door closes. These are known as inductors. What an inductor does, or what the coils are doing, is they're fighting a change of magnetic field. A resistor just fights the current. Whichever direction the current's going, the resistor tries to slow it down. Or not try to, it does slow it down because there's something in the way of the electric current. In this case, when you put current through this solenoid, and I don't know how this one is wrapped, apparently it's wrapped this way, so as current is flowing this direction around the solenoids, a magnetic field is going this direction. Well, by Lenz's law, it opposes that change of magnetic field, which causes current to flow the opposite direction, which resists the current. By putting the iron through the solenoids, that increases the magnetic field because it changes from air to iron in the center of the coils. That causes the magnetic field change to be greater and causes it to fight it even more, causing a greater delay in the current flowing through the light bulb. That's all there was to that.